Okay, I'm going to start with 10.1 because I like it. Okay, so 10.1, we're learning about real numbers. Okay, so, and we've mentioned this a little bit in the past, but now we're going to really go more into this. So this diagram is showing the different sets of numbers. So they're each one nested inside of each other. So the smallest one in the center is the natural numbers. So natural numbers are also sometimes called the counting numbers. So it starts at 1 and it's just all the whole numbers counting up from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up through a million, billion, whatever. All right. And then outside of that, we have the whole numbers. So there are only one number different between the whole numbers and the natural numbers, and that is 0. So 0 is the only number that is considered a whole number, but not a natural number. So all natural numbers are whole numbers. And then outside of that, we have the integers. So the integers includes all of the whole numbers, plus it also includes all of the integers. I'm sorry, all the negative whole numbers is what I meant to say. Includes all the whole numbers plus all the negative whole numbers. Okay. And then outside of that, we have rational numbers. So rational numbers includes all of the integers, plus it includes anything that can be written as an integer over another integer. So in other words, fractions. And most decimals are also going to be rational numbers. For example, if you had like say 0.3, that would be the same thing as 3/10. So that would be a rational number. So any terminating decimal is a rational number. That means if it's a decimal that doesn't go on forever. Also, any repeating decimal is going to be a rational number. So if it's 0.333333 and it repeats forever, well, that's also known as 1/3, which is a rational number. So most decimal numbers that you see will also be rational. So if it's a terminating decimal, meaning it stops at some time and doesn't go on forever, or even if it does go on forever, if it has a repeating pattern, so it could be 0.123, that keeps going forever, then that'd be a rational number as well. So then outside of that, you have real numbers. So all of these that we've talked about are part of the real numbers, but real numbers also includes irrational numbers. So numbers that are not rational, such as the square root of 2. All right. Okay. All right, so let's look at some questions. Question number 1, which of the following is not an integer? What do you think? Yeah, a lot of people say C, but the square root of 100 equals 10, and 10 is an integer. So it's D, because that's a decimal. So decimals cannot be integers. Number two, which of the following is a natural number? So since the square root of 100 equals to 10, then yes, this is the answer, C. All right, so notice by saying that, I am saying that these other three are not natural numbers. So 0 is not a natural number, a negative cannot be a natural number, and a decimal cannot be a natural number. And then number 3, which of the following is not a rational number? C is the correct answer. That's pi. So if you went to middle school math teacher's classroom, you might see a border that goes all the way around the whole classroom of the digits of pi, right? So 3.1415, blah, 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 blah. It goes on forever. So that is an example of an irrational number. Since it's not rational, that could also be described as irrational. Okay, now all the rest of these options are rational numbers. Okay, so, you know, negative 22, that's an integer. So just think if it can be written as like an integer over an integer. So like, you know, any integer is automatically a rational number because it could be written as negative 22 over 1. 0 could be written as 0 over 1. And then remember, like I said, any terminating decimal. So it's a decimal, but it has an ending point. It doesn't go on forever. So that's what they mean by a terminating decimal. So that's rational as well. And you could also show that that could be written as an integer over an integer. Like, let's see, so that would be 40, that'd be the same thing as 45 over 10, basically. So, yeah. Okay. Okay. At this point, I want to go ahead and give you the test review because there's something on there that I want you to look at. And it's on like the second to last page is what I want you to look at right now. Did I give you this already? I don't think so, right? Okay, so just for an example, maybe to put this in terms of something you're a little bit more familiar with, let's just say that I had a diagram like this, where I had this blob represents real things, and then I had one that means food. and one that was candy. Okay, so if I wanted to fill things into that diagram, I could put M&Ms in the center. Because M&Ms is a type of candy, but M&Ms is also could be considered a type of food, and it's also a real thing, right? But I don't need to, when I write it in the inner circle, I've already written it in, it's already inside all the other circles. So I don't need to keep writing it 3 more times or 2 more times or whatever. And like I could put here bread, because that's a type of food, but it's not candy, but it's also a real thing. But I'm only writing, my point is I'm only writing each thing one time, and just write it in whatever the smallest circle is that it would fit into. Okay, and over here I could have like house, right? Makes sense what I'm trying to say? And so I already wrote on this apparently. I saved it. But. So just showing some examples of, and these are not the ones from the list. I just made up some other ones to show where numbers would fit in here. So like the square root of 10. So unless it's a perfect square, like 4 or 9 or 25 or 16, those are perfect squares. So if I say the square root of 25, that's the same thing as 5. So that's why it goes in there. But the square root of 10, you know, that's just going to be some decimal. So so that goes over here under real numbers. So that would actually be an irrational number. Okay. And the only number that ever goes in this area is 0, because that's the only number that's a whole number that's not natural. Yeah, I wasn't doing these. I was just giving some other examples. Yeah. All right. So I could say like, you know, 1/2 would go here. In here could be something like -10. All right. Any questions about this? So, you know, so if you were asked like, is 5 a real number? Yes, it is. Is 0 a rational number? Yes, it is. It is, because real numbers encompasses all of that. Well, there's really not, there's imaginary numbers that are outside of that, but we won't even go over that this semester. So basically all the numbers are real numbers that we're going to talk about this semester. There is such a thing as imaginary numbers that are not real, but we won't talk about any of that this semester. That's right. -10 is a rational number. That's right. -10 is not a whole number, because whole numbers are only positive, 0 and larger. Okay. Any other questions about this? Okay. Let's look at the notes again. So page 2 of 10.1 is about inequalities. So it's just a really brief introduction to the concept of inequalities and knowing what the symbols look like and how to read them. So And there's several different ways that people use to remember how to read these symbols. So one thing that comes to mind is the fact that this symbol is kind of close to an L for less than. X is less than 3. All right, so X is less than 3, Y is greater than 2. So if that's less than, flip it around, that's greater than. And then if either one of the symbols has a straight line underneath it, that means or equal to. So A is less than or equal to B, 5 is greater than or equal to N. So write a different inequality with the same meaning as 9 is greater than P. So that's the same thing as saying P is less than 9. And number 5, write an inequality meaning G is less than or equal to -4. So that looks like this. True or false? -7 is less than 0. That is true. Number 6, oops. Number 6 says 5 is greater than or equal to -2. True or false? So someone always says false, but it's actually true. So why would someone say false? So it's not equal, but it's greater than or equal. It's never going to be both, right? It's going to be one or the other. So it is greater than, so therefore that's true. You could also say 5 is greater than or equal to 5. That's the one where it's equal. That would be true as well. Okay, number 8 says 8 minus 3 is not equal to 2 times 3 minus 2. So simplify. 8 minus 3 is 5. And 3 minus 2 is 1. 2 times 1 is 2. So once we simplify everything, it says 5 is not equal to 2. And that's true. Number 9 says -2 minus 3 is less than or equal to -10 plus 5. So simplify each side. So -2 minus 3 would be -5. And -10 plus 5 is -5. So -5 is less than or equal to -5. True. All right. Okay, so then we'll move over to chapter 9, which is about charts, graphs, tables, etc. like that. And some of these are kind of hard to see. Let's see, it's not too terrible. Okay, so this first is a pictograph. And so each one of those little pictures, it's supposed to be a picture of like a stalk of wheat. And there's a key down at the bottom of it, which says that each one of those pictures represents 1 million acres of wheat. And question number 1 says, which of the states shown plant the least amount of wheat acreage? So that would be Colorado and Washington. They only have 2, and all the other ones have more than that. Number 2 says, approximate the number of acres of wheat planted in Kansas. So 1, 2, 3, 4, 5, 6, 7, 8, and this one is actually like a half. So 8.5 million. Number 3, which state plants about 4 million acres of wheat? So that is Texas. Oklahoma is actually 3.5. Of course, we're better than them, as always. All right. All right, here's another pictograph, and each one of those little pictures of a fire represents 12,000 fires in the wildfires in the U.S. So question number 4 says, approximately how many wildfires were there in 2006? So 1, 2, 3, 4, 5, 6, 7, 8, and we need to multiply that times 12,000. So 8 times 12 is 96. So that's 96,000. Number 5 says, in what years were the numbers of wildfires greater than 72,000? So first I'm going to do 72,000 divided by 12,000 to see how many pictures I'm looking for. So basically the 1,000 cancels out, and I'm just saying 72 divided by 12, which is 6. So 1, 2, 3, 4, 5, 6. So 2002 has like a little bit past that. So that's going to be one of them. And then 2006, 7, and 8 are past that. Number 6 says, how many more wildfires were there in 2006 than in 2005? So 2006, you have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 12,000 is 96,000. Oh yeah, we already answered that in the previous question. So okay, 96,000. And then for 2005, we have 1, 2, 3, 4, 5.5. So subtract 5.5 times 12,000. So that'll be 66,000, I believe, when you multiply that. So that'll equal 30,000. And what was the percent of increase in wildfires from 2005 to 2006? So that's going to be the amount of the increase, which we just calculated was 30,000, divided by the earlier amount, which is going to be the amount from 2005, which was 66,000. So I can cancel out the 3 zeros on the end. So it's basically 30 over 66. I can reduce that by 3, or actually 6. Yeah, 6 goes into 35 times, 6 goes into 66 11 times, so 5 over 11. And I want to change that to a percent, so I have to divide 5 divided by 11. So 11 doesn't go into 5, but 11 can go into 50 4 times. 44, 6. So let's just say we round this to the nearest hundredth. So it's going to be approximately 45%. All right. Next, we have a bar graph for hurricanes making landfall in the US, broken down by month. And in which month did the fewest hurricanes make landfall? So that would be June. Just that's the shortest bar on the bar graph, so that's it. Next, we have another bar graph showing the world's largest cities and their population. And the question is, name the 2 cities that have approximately the same population. Now, it's kind of hard to tell for sure exactly. If this was on the homework or a test, I would, we would make sure that it was a little bit more clear, but I believe it looks like the closest is LA and Shanghai with approximately 18 million. Number 9 says, how much larger is Mexico City than Shanghai? So Mexico City looks like So that would be approximately 23 million for Mexico City. And then Shanghai, like I said before, it looks like approximately 18. So minus 18. So that would be 5 million. All right. And this graph looks like it's based on a survey of a small number of adults asking like how many miles per day do they drive. So how many are between 200 and 249 miles per day? And so that looks like approximately 9. And then the next question says, how many adults drive between 150 and 249? So we would have to add up 2 of the categories for that. So 150 to 199 also looks like 9. And then add the 200 to 249, which is also 9. And so 9 plus 9 is 18. The next one is showing the age of householders. So it says least number of householders in what age range. So that's obviously under 25. That's the shortest one. All right, next we have some pie charts, which are also sometimes called circle charts. I'm missing some text here. All right, so for a particular campus, it's showing how many students have what type of housing. So besides other arrangements, where do the least number of students live? So that would be own off-campus housing. Find the ratio of students living in off-campus rentals to total students. So first we would need to calculate the number of total students. So we would add up all of the categories. So like 180 plus 320 plus 124 plus 62 plus 14. Add all of those up. That'd be 700. And then off-campus rentals is 124. So 124 over 700. We can reduce that by 4. It reduces to 31 over 175. Okay, and the next pie chart is showing the percent of the Earth's landmass that's taken up by each continent. So which continent is the smallest? That's going to be Australia. And what percent of the land on Earth is accounted for by North and South America? So North America is 16% plus South America, which is 12%. So it's 28%. And then another pie chart showing the percentage of different types of books in a library. So what percent of books are nonfiction or reference? So nonfiction is 25% plus reference is 17%. So add those together, that's 42%. All right, and if this library has 125,600 books, how many books are reference? So we would have to multiply 125,600 by 0.17. And 2 of those digits have to be after the decimal point. So the answer is 21,352. All right, so that's all. And our test is 1 week from today. You have your test review The answers are on Canvas. Make sure you're doing your homework. See y'all Wednesday.